Okay, so let's talk about what makes good hypotheses. And what makes good experiments. We talked about these as being foundation of the scientific process in the last video. Okay, what are the tenets, characteristics of good hypotheses and good experiments? So remember, we start with hypothesis. This is the proposed answer to our question at hand. So for example, one of the questions that's come up recently is this drug hydrochloroquine and whether it can be used as a therapeutic drug to test patients with COVID-19, right? So the first thing in a good hypothesis is obviously it needs to be logical, right? That is, considering what we know, is it even a possibility that this would be the right answer to our question? And so in this example, hydrochloroquine, this is a drug that has been used as an anti-malarial. It's also used as an anti-rheumatoidal therapeutic drug, help people with rheumatoid arthritis. And so the way that the drug works, as I understand, is it changes the internal environment inside of a cell, changes the acidity or the pH of that cell. And so the thought is that it would make the inside of the cell less conducive to the virus transmitting to the person. So yeah, this would meet the logical prerequisite. Okay, a good hypothesis is also something that's testable. Okay, meaning it has to be based on a measurable outcome. Okay, that it can't be very complex, right? A good hypothesis is something that is really relatively simple, and with a good, elegant experiment, we can come to a conclusion. And whether or not this is a supported hypothesis, really, we're going to see that there's two conclusions at the end of our experiment. Is we don't prove our hypothesis, we either support the hypothesis or we disprove, really, which brings us to our third major tenet here, is that hooked on phonics here, falsifiable. In other words, we need to be able to collect evidence that will disprove or winnow out this hypothesis. We need to be able to provide results that fly in the face of the prediction and will falsify or get rid of this hypothesis. We want to remove it from the table and say that it's no longer a good hypothesis. It's going to get us closer to the right answer, as to be able to disprove or falsify our hypothesis. And so I think that those really are the main tenets. Again, it needs to be something measurable, something predictable. It takes us back to our conversation about supernatural phenomenon, right? It needs to be something that is based on a natural, predictable, measurable phenomenon. So we come up with our hypothesis, make a prediction based on that, and then we're going to try to design a good experiment in order to test our predictions that come out of the hypothesis. Okay, and so some things that are have got to be there in order for this to be considered a good experiment. Right? Is one, the experiment needs to be replicated. So in this example, there was a big couple of studies that came out to test the hydrochloroquine hypothesis that it would reduce infection rate. And of course, we are not going to just give the hydrochloroquine to one person and then measure the outcome of whether or not they become infected with the COVID virus, right? So in fact, the largest experiment that was conducted, I believe there was 63,000 people that were included in the study. We know that it's important to replicate because there's variation in people's response to a drug, right? So we have genetic variables, we have variables such as their health, previous health issues, socioeconomic status, and so we need to include all the people that cover all that different components of variability so that we can make sure that the drug doesn't work on just one person, but that we can take the inference that we have gained from our study population and extrapolate to the larger population. So we always want to replicate. The more replications, the better. Okay. Good experiment is going to be a controlled experiment. Okay. So in pharmaceutical type of studies, the sort of gold standard for controlled study is that we use twins, identical twins. Again, going back to sort of related to the replicated study idea is that we want, if we see a result that the transmission of the virus is reduced, we want to make good and sure that the reason that the transmission was reduced was because of the administration of the drug. It's not because the person that took the hydrochloroquine also was working out more, or that person that took the hydrochloroquine also happened to, not be obese, right? So all these variables that also affect whether or not you're going to be infected by the virus, we want to control those so that any result was caused by the variable of interest here. So a lot of times how this is done is you give a placebo to a group of people, and that may be just a sugar pill, something like that, and then you want to make sure that just the simple act of taking a pill, going to the doctor, going through the whole routine of being seen, physically examined, and then being given some type of pharmaceutical drug does not impact whether or not somebody is infected. And it's funny we say that, but there is a measurable placebo effect. It's very consistent across studies that people feel empowered by taking some type of drug. So the placebo helps us to control that. These epidemiological studies use statistics to control for all these other variables: gender, race, age, body mass index. All those things have to be controlled. And then the other thing about an experiment, and this is, I don't know how else to say this besides to say, well, okay, there's two different kinds of, here we go, observational experiments versus manipulative experiments. Manipulative. So I said in the last video that not all evidence is weighted equally, right? You can gather evidence that is very, very strong evidence. It will never prove that your hypothesis is true, but it does more to give us more support for the hypothesis. So in this example, really the experiment by nature has to be observational, because the manipulative experiment would be you give a group of people hydrochloroquine, you give a group of people placebo, and then you expose both of them to the virus and then look to see what the outcome is, which obviously is not feasible because of the ethical considerations. So instead we rely on these observational type of studies where, and this will be forthcoming too with all of the different vaccines that are coming online, that we need to give the vaccine to a whole bunch of people in a replicated situation. We need to try to control for different variables, and then we're going to look to see, we can't really expose that person to the virus, but we'll see, considering all the risk factors, whether or not they will become infected with the virus. So these are more of an observational study. We just observe to see what happens, right? But the gold standard would be a manipulative type of study where you would, make sure that that person was exposed to the virus. But again, there's limitations to science, and especially in this type of situation here. So I think those are the big things. I know you guys have a question on your essay this week about designing a hypothesis, and then or formulating a hypothesis, then designing an experiment to test that. So this might help you to kind of get started thinking about those.